Hello, you are welcome to Maths Clinic Series. In this video, we are continuing the series of permutation, and the previous two videos before this one, we were looking at conditional permutation, and we want to continue with the conditional permutation. This time, we're looking at arranging digits with and without repetition. Mostly with repetition is very easy to handle, but the challenge is when we come to without repetition. So I'll just give you some emphasis on the repetition, with repetition, then we'll stretch much on without repetition. So by the end of this video, you should be able to arrange digits in a row with or without repetition. So with example, we have given the digits 1, 2, 3, 4, 5, 6, 7. In how many ways can this be formed? In how many ways can we form a 4-digit number? Then 2, a 4-digit number which is an even number if no digit is repeated. Now, if we are to do with repetition, we'll look at it. Then without repetition, actually without repetition, if you are given 7 different numbers and you are to form a 4-digit number out of it, it's very simple. You can just say 7 permutation 4. That's what we did earlier on. But this time around, there are other conditions that will compel us to do something different. Okay. Now, let us assume that I want to deal with repetition. In how many ways can we arrange 4-digit number if any number can be repeated? So we'll ask ourselves, how many ways can we position any of this number in the first position here? And that's going to be 7 times, obviously, because any of them can be used over here. Now, assuming one of them is taking position over here, let's say 1 has come here. How many ways can we arrange this? I'm sure you will see 6, but that's not true. It should be 7 because we are saying with repetition, it means 1 can repeat again. Even though 1 has positioned itself, it can also be repeated again. So it means any of this all can be positioned here. And so that's going to be 7 different ways. Then when you come here, let's say 2 take a position here. So 2 can be repeated. So again, all of these numbers can be positioned here again. And so that becomes 7 times 7 times 7 times 7. So it's same as saying 7 exponent 4. And then the answer comes. So if it comes with repetition, there's no problem with it. It's very easy to handle. But this is the case we want to look at it in terms of without repetition. So forming the 4-digit number, that is very easy. Any of this can be positioned here. So the first can take 7. And because without repetition, the second position can take 6. Because if you position first in the first place, then we have 6 left to position in the second position. And then the third will be 5 and then 4. And this will give you 840 ways. And the same as saying 7 permutation 4, as we said earlier on. Then the second question says, in how many ways can we form the 4-digit number if that 4-digit number ought to be even number? Now, for us to form an even number, we all know that even number always ends with either 0 or an even number or multiple of 2. All right. Anytime we have the last number of a number ending with either 0 or any of the even numbers, that is from 2 up to 8, then that number is considered to be even. If I have 1, 3, 7, 4, this is an even number. So it means that the last end here must automatically be any of these numbers within the set of numbers given us. Because the set of numbers, we have only 2, 4, 6 as even numbers. So any of these 3 can be positioned here at any point in time. So the question is, how many ways can we arrange this particular position? That's the last position. And that's going to give us 3 ways. And so that 3 can be taken outstanding. Then we are left with 3 different slots. And the 3 different slots, any of these numbers can be positioned in the first. But then the moment you position the first number or the last number here, one of them comes here, then we'll be left with how many to be positioned? 6, right? So the first number can take 6, any of the 6, the remaining 6. Then after positioning the 6, then the next number will be how many ways can we position the next number? Good. That will be 5. Then the next number will be 4. And then we multiply by the 3, and the result comes as 360. If you want to use the formula for this, then we have to consider the fact that the 3 numbers here can be positioned in 3 different ways. So the 3 becomes an outstanding. Then we are left with 6 numbers because we will position 1 here. We're left with 6 numbers and we have only 3 slots to select from. And that is going to give us 6 permutation 3. Then we multiply by the outstanding 3 and the answer will come as 360. Good. So that is how we solve this. More examples will help you to understand better. Example number 2. In how many ways, or in how many numbers greater than 200 can be formed using the digits 1, 2, 3, 4, 5 if no digit may be repeated? In how many numbers greater than 200 can be formed using the digits 1, 2, 3, 4, 5 if no digit may be repeated? Now, we are looking at a number that is greater than 200. Take note of that. And they didn't specify the number of digits they want us to form. And so what we have to do is we have to form numbers that are greater than 200. And a number greater than 200 can be 3-digit number, can be 4-digit number, can be 5-digit number. And remember that since we have 5 digits, we can create 5-digit number. For example, I can say this one as 12,345. So we have to take them step by step, okay, in doing it, step by step in doing it. So let's first take the 3-digit number. 3-digit number. Now with 3-digit number, realize that we can't start with 1 because when you start with 1 and you put any number after 1, you always get a number that is less than the 200. So 1 is out. 2 is accepted because the moment I position 2 and I bring even 1 and then 3, I've gotten a number greater than 200. And so what we have to think of it is that 1 is out of 3-digit number to start a number with. But 1 can be positioned anywhere apart from the first number. So the first question is, how many ways can we position this place with the remaining numbers? And that is 4. Good. So that will be 4 ways. Then we put our 4 ways there. Then once we position the first to be 4, how many ways can we position the second the second digit? And this time around, 1 is included, making 5. But we've already taken position to 1, or the first has taken position already. So the remaining is no longer going to be 5, but rather 4. So the next will be 4 ways. Then once 2 has taken position, then the remaining will be 3 ways. So for the 3rd digit, we can just do that in 48 ways. Is that okay? Good. Then let's look at it in terms of 4-digit number. Now 4-digit number, because any 4-digit number will always be greater than 200, that means any of the positions can take any of the numbers. So the question is, how many ways can we arrange 5 numbers if 4 slots are given? And that is obviously 5 permutation 4. Or the first can take 5 ways, second can take 4, 3, 2, and that is it. If I multiply all these together, I get 120. Now the next one, which of course is also very easy, if I have 5-digit number to form out of 5 numbers, I'll get 5 permutation 5, which is 5 times 4 times 3 times 2 times 1. So when I put all these parts together, I get 288 ways. I hope it makes sense. If I want to do this with the formula work, I'll just say the first one will give me 4 times 4 permutation 2. Let me explain that further. The first one, you see, we said that since this is totally out of the equation, we have 4 ways in which we can position the first number because 1 is out. Now, if 1 is out and we have 4 ways of doing it, then we are left with 2 slots. And the 2 slots, how many numbers are left? 4 numbers are left, because first has taken the position. So the 2 slot means we have 4 numbers, we want to select 2. And so we get our 4 permutation 2. And then we add it to 5 permutation 4 and then 5 permutation 5. And together will give us the 288. Now, for example number 3, you can pause the video and try your hand on it. And I'll brush you through the solution. Alright. So how many 4 and 5 digit number can be formed using the digit 2, 3, 4, 5, 6? No repetition. And then how many of them will be greater than 300 and how many will be even numbers? So for them to be greater than, so for us to get the 4 digit number and 5 digit number, 4 and 5, we take the 4. Of course, that is very cool because there's no condition here that makes it to be greater than a particular number. So we look at how many ways the first can be placed, and that is 5 different ways because we have 5 numbers involved. The next will be 4, 3, and then 2. Then 5 digit numbers also will be the same thing because all of them are supposed to be selected. So 5 factorial ways, which is 5, 4, 3, 2, 1. And then we add the 2 together to get 240. All right. The second question is very easy because how many will be greater than 300? At least 4 digit, 5 digit numbers, they are all greater than 300. So that is more or less doing the first, what we did right now, and you just add and you get 240 the same way because all numbers will be greater than 300. The last one, that is where the problem lies. How many will be even numbers? How many of the 4 digit numbers and the 5 digit numbers are going to be even? So for the 4 digit number, of course, we know that the last digit must always stay the 246. That is in the question. And it can be 3 different ways we can arrange that. Okay. Then we come to the first set. The remaining 3 here. The first slot here can receive 4 different numbers because one of them has already been positioned here. So the remaining will be 4. So that will give us 4 ways of doing that. Now that we've positioned this and we position this, we are left with 3 different numbers, and any of them can fill this one. And so that will give us times 3 and then times 2, and then we multiply by the 3 here, and then the answer will come 72. Then for 5 digit number, we go through the same process. The last will take 246, which is 3 ways, and the remaining 4, we are going to have 4 permutation 4. Yeah, 4. So that is going to give us 4 times 3 times 2 times 1. And so that also will give us times 3 here, 72, and we add and we get our answer as 144. Wow. Okay, so the next question, go through it. Take your time and go through it. I'll give you only the answers and you have to go through the answers on your own. Since I don't have time, I need not to go beyond 15 minutes of my recording time. And so here we are looking at how many 4 digit number greater than 3000 can be formed using 1, 2, 3 up to that. No, with repetition and without repetition. So the answers will come as such. So then with repetition, this is what's going to be. You go through it and you will understand. Then without repetition, we get this one. And then the last condition with even numbers, we go through that. And that becomes this. The next question, which is the last question also, you can go through that also systematically. And then you get your answer. Right. So with this answer, we come to the end of this section of the video. Look forward for the next video, which will talk about cyclic permutations. Stay blessed. Enjoy the rest of your day.